Hello everyone, this is Ayesha. Today we discuss about the Compton effect, which is there in the chapter Atomic Structure and Elementary Quantum Mechanics. So here, the Compton is a name of a scientist. He introduced this effect or this theory in the year 1923, and this theory is based on the quantum theory or the photon theory. Already we had discussed about the quantum theory, right, in the previous classes, where we have seen that according to the quantum theory, the energy is present in a discontinuous form or in the form of quanta, right? So, based on that theory, he states that when X-rays of high energy are allowed to fall on a solid matter like carbon black or some other light elements, an electron is ejected from the carbon black and X-rays scattered from their original path possess longer wavelength than the incident X-ray. So this statement you can better understand by seeing the diagram. So here we are having the incident photon, and here once you pass the radiation on the metallic surface, so here in the place of metallic surface we are using a carbon black. So once you pass the radiation which contains the photon on the carbon black, the ejection of electrons will be taking place. So here you will get the scattered photon and here you will get the scattered electron. So initially for the incident photon, the energy equation that is E is equal to h nu, where E stands for energy, h for Planck's constant, and nu for the frequency. So for this equation, which is equal to hy by lambda, and its momentum will be is equal to h by lambda. Now we'll see the energy equation of the electron which is at rest place, right? So here at carbon black, the energy of equation that is E is equal to m0 c square, or you can call as m naught c square, where its momentum value will be m is equal to m0 is to v0, which is equal to 0. So ultimately, the energy equation over here, as it at its rest place, that therefore it is representing with a 0 number. So m0 c square, and its momentum is also is equal to 0. Now, once the radiation pass on this carbon black, the ejection was taking place. So this scattered photon is having the energy equation that is E is equal to h nu, which is equal to hy by lambda prime. And its momentum value is m is equal to h by lambda prime. So now you just compare the scattered photon with that of the incident photon, where its energy, right, just to distinguish the incident with that of the scattered, or you can call as a transmitted photon. Therefore, we are distinguishing with a prime symbol. So here you are getting the E is equal to hy by lambda prime, whereas here we had written as E is equal to hy by lambda. And here the momentum was is equal to h by lambda. And just to distinguish with that of the transmitted photon, we got the momentum as is equal to h by lambda prime, right? So that is the energy and momentum of a scattered photon. Now, here the ejection leads to give you a scattered electron, where the energy equation is equal to mc square and momentum equation is equal to mv. Now, the angle present between this incident photon and with that of the scattered photon is called as angle of scattering, which is generally represented with the symbol theta. The angle present between the incident photon, right, the dashed line which I am representing over here, that is your incident photon, and with that of the scattered photon, or you can call as scattered X-ray. So this angle is called as angle of scattering, which is represented with a theta sign. right? So based on this, the Compton have stated that when X-rays of high energy, or you can simply call as when the radiation, X-ray radiation, fall on a carbon black, the electron ejection will be taking place. And here the X-rays of the scattered photon from the original path possess a longer wavelength than the incident X-ray. This point you have to remember under the Compton effect. Now moving with a next point, that is, as we know, the Compton says that the ejection of electron is taking place only when the scattering of X-ray is possible, only when X-rays consist of a particles, right? That is, here when the light is present in the form of quanta, or if the light have the particle nature, then only the Compton effect is possible. And if the light is in continuous form or in wave nature, then this effect is not possible. That's what we have to make a note over here. That is, Compton argued that ejection of the electron and scattering of X-ray is possible only when X-rays consist of particles, which are also called as photon. And if X-rays would be a continuous wave, then neither electron should be ejected nor incident X-ray should be scattered. Therefore, it has been found that the scattered X-ray have longer wavelength than the incident X-ray. This point already we have seen when we were discussing about the structure, the diagram, right? So scattered X-ray have a longer wavelength than the incident X-ray. So whenever we are saying longer wavelength, ultimately it is having the lower frequency, or you can say as the lower energy, right? So that is like about the wavelength. Now we got the definition for this Compton effect as the phenomena, means the incident, like the radiation pass on the metallic surface, right? Once the radiation pass on the metallic surface, the ejection of electron was taking place. So this phenomena in which there is a change in the wavelength of the scattered X-ray is called Compton effect, right? Where there is a change in the wavelength of the scattered X-ray, then this phenomenon is called as the Compton effect. And the angle through which the incident X-rays are deflected from their original paths is known as angle of scattering, and is also represented with a term or with the symbol theta. So here the theta is the angle present between the incident and the scattered X-rays. So that is the important points which we have to remember under the Compton effect. So first we have to give the statement followed with the respect to the particle nature. Next important point you have to remember is here the scattered X-rays have a longer wavelength than the incident X-ray. Next, the angle present between the incident X-ray and the original path is called as the angle of scattering, which is represented with a theta symbol. Now, based on this assumption, right, that is the photon electron collisions to be perfectly elastic. Why we are calling as photon electron? Because just see the diagram over here when we were discussing under the Compton effect. So it is the diagram between photon and electron collision, right? So that's why we are saying by consuming or by assuming photon electron collisions to be perfectly elastic, Compton found the shift in the wavelength, which was given by the expression that is d lambda is equal to 2 lambda by mc sine square theta by 2, right? So this equation is called as the Compton effect equation, which is very, very important. That is d lambda is equal to 2 lambda by mc sine square theta by 2, where lambda already we know it's called as your wavelength, and m stands for the mass of an electron, c stands for the velocity of light, and theta stands for the angle of scattering, right? So this equation shows that the d lambda is independent of the nature of the substance and the wavelength of the incident radiation, right? So this statement at last you have to give based on the equation. So this is all about the Compton effect. So in the exam, if they ask you about to describe about Compton effect, then first point you have to say that here it is based on the quantum theory. Then the statement you need to give it. So after that, you need to describe about the picture, that the diagram, how the ejection of electron is taking place. Next, after that, you need to say this effect is possible only when the light exists or consists of a particles. Next important point, here the wavelength of the scattered X-ray is greater than the frequency. Now, the angle which is present between the incident and the scattered photon is called here angle of scattering, which is represented with a theta. So based on this theory, we got the Compton effect equation, that is d lambda is equal to 2 lambda by mc sine square theta by 2, right? So with this, we have completed the Compton effect. I hope it's clear. Okay, thank you for listening.